Hello friends, welcome to MG Engineers Academy. Today we are going to discuss property number 3, that is division by T. In last session we discussed some problems related to property number 2, that is multiplication by T. So today we are going to discuss property 3, Laplace form. T division by T. What we have to do now? We have to mention if we have Laplace f of T is equal to f bar of S bar of S, then prove that we have to prove we have to prove Laplace f of t on t is equal to integration s to infinity f bar of s ds. So what we have given? We have given Laplace f of t is equal to f bar of s, and we have to prove Laplace f of t upon t is equal to integration s to infinity bar of s ds. So we have to prove this. Now how we are going to prove that answer? Whenever you get the question to prove something, right? Now we also here receive the question for to prove that, right? Then in that case, if there is integration or derivative, if there is an integration or derivative, okay? If there is an integration on derivative, any side, either it's on left hand side or it's on right hand side, we are going to take that side first to solve the problem, and based on that integration or derivative we are going to prove the remaining side. So इस केस में क्या हुआ है, इंटीग्रेशन हमें राइट हैंड साइड पे, राइट हैंड साइड। नाउ जब भी आपको अगर प्रूव दैट करने का क्वेश्चन आता है, एंड इन दैट प्रूव दैट क्वेश्चन, अगर लेफ्ट हैंड साइड और राइट हैंड साइड में जिस भी साइड में अगर इंटीग्रेशन और डेरिवेटिव हो, उस साइड आपको फर्स्ट लेना है, मीन्स उस साइड को लेके आपको प्रूव करना है रिमेनिंग साइड। सो इन दिस केस क्या है, राइट हैंड साइड हमारे पास इंटीग्रेशन है, सो वी आर गोइंग टू टेक राइट हैंड साइड। अगर है लेफ्ट हैंड साइड पे अगर होता है डेरिवेटिव और इंटीग्रेशन, तो हम लेफ्ट हैंड साइड लेते। नाउ इस केस में राइट हैंड साइड पे, सो राइट हैंड साइड आई एम गोइंग टू टेक राइट हैंड साइड। इट इज राइट हैंड साइड s to infinity, integration s to infinity f bar of s into ds, right? So what we have, f bar of s is Laplace f of t. So integration s to infinity Laplace of t, right? Now we have Laplace formula. Laplace f of t is equal to integration 0 to infinity e raised to minus st f of t dt. So at the place of Laplace f of t, I am going to mention this equation, right? So it's to infinity e raised to minus st. I am going to write equation of Laplace at this place. So we have to integration s to infinity as it is. And I will write in bracket what is the value for this one, right? So I'm going to write 0 t e raised to minus st f of t, right, into dt into ts. Rest things are same, only I did at the place of f bar of s I have mentioned Laplace of f of t, and at the place of Laplace of f of t I have mentioned the equation of Laplace. That's it. No any additional step. I just enter the value. Now here we have double integration, means integration with respect to s to infinity and integration 0 to infinity, right? So what can I do? Now in this step I am going to exchange the integration sign. So I will take inside integration outside and outside integration inside. Same way I am taking outside ds value inside and dt outside. So what I will get 0 to infinity. Integration 0 to infinity. I will make a bracket integration s to infinity e raised to minus st. Right? At the same time, I will also take this function value outside. Right? F of t bracket integration s to infinity e raised to minus st ds to dt. So it will be easy for us to integrate this e raised to minus st with respect to ds. Okay, so we have the limit from s to infinity. So what I can do, I'm again rewriting this equation 0 to infinity f of t get integration s to infinity e raised to minus st to ds into dt. Now what is the value for integration e raised to at? The standard value. So e raised to 80 dt. What is the standard value? E raised to 80 upon a, right? This is the standard formula for integration. So we are going to apply the same logic here. Integration 0 to infinity f of t e raised to minus st upon here. Yes, we are integrating with respect to s, so t is the constant, and here we have minus sign, so I'm going to mention minus sign minus t into dt, right? We deal the integration for this term. So next integration 0 to infinity f of t, right? Here I mentioned, forgot to mention limit is to infinity. So I'm going to put the upper limit and lower limit in this integration value e raised to minus s. I am going to put value of s as infinity in this case e raised to minus infinity into t, right? Minus t minus e raised to minus s e raised to minus s into t, right? Is to minus s to t on t into dt, right? So further simplifying it 0 to infinity t f of t e raised to minus infinity into t, anything into infinity will be infinity minus t, e raised to minus st upon t minus t dt. Now, what I am going to do? Integration 0 to infinity. What value we have in integration minus e raised to minus infinity is the 0. F of t 0 upon minus t. This minus and this minus will get plus e raised to minus st t dt. What I will get now? Integration 0 to infinity of t into e raised to minus s upon t dt. So what I am going to do now? I am going to rewrite this equation. What I am going to do now here integration 0 to infinity e raised to minus st f of t by t dt, right? So what is the equation of Laplace? Laplace f of t is equal to integration 0 to infinity e raised to minus st f of t into dt, right? So it is in the same format, right? You can see here we have integral part, exponential part, or f of t part. Okay, means whatever f of t is outside, the same f of t value will be the inside, right? So if we have f of t value is like that, then what we are going to do? We are going to mention f of t value will be f of t by t into dt, right? So it is in our format. So I'm going to write Laplace of f of t by t, right? So is this? This is left hand side, right? What is the left hand side? You can see here. So you can see this is the left hand side which we have to prove, right? I hope you got the clarity on this equation. So if you have any doubt, please comment me in the comment box so I can assist you further. Thank you.